All right, you are here for the talk, Caching with PSRs. That's a little bit different than what's on the schedule. On the schedule, it says Caching with PSR-6 and PSR-16, but that's a little bit long, so I abbreviated it. You can tweet with hashtag DPC and mention my name. It's a bit long, but at least try. So my name is Hannes, and I can describe myself in a couple of emoji characters. I'm a Belgian. I like running. I like working with computers, like most of you. And I also love working with people. The last one is not really the official heart emoji, but it's the company logo. I work for a company called madewithlove.be. It's a Belgian company, but we do remote work. So we used to have someone in Amsterdam, but he decided to switch to Schiphol, which is also a good employer. We have people in Brazil, Canada, all over the place, basically. We do PHP and JavaScript development for clients. We are still looking for a senior developer for one of our biggest clients. It's a reasonably big project, like 700K euros. And we are also looking for, maybe this is not the audience, but for 2 React and React Native developers. So if you're interested in remote work and that kind of stuff, you can always contact me, or you can always ping me for stickers. We have heart-shaped stickers with this. So that's the vendor pitch. I'm going to stop talking about Made with Love now. I'm going to start talking about the actual topic. The actual topic is caching with PSRs. And for that, I'm going to go way back before the PHP fig was around and how we did caching back then in frameworks and libraries and stuff. So it's basically a timeline. Caching before 2015 and caching from 2015 onwards, still today. So the introduction, what is caching? Some of you may not know what caching is if you don't have high loads, if you have never come across a situation where you have to use it. Basically, caching is speeding up your application by shortcutting slow-running things, slow-running executions. It's based on 3 steps. You query if the storage has a value. If not, you are going to execute the slow-running task, and then you are going to remember the result for the next time. Rule number 1 of caching: your app should not fail when your caching is disabled or when something is wrong with your caching layer. You've all seen the moving images on my screensaver. That is cached as well locally. But when the cache is disabled, it should still work. If it stops working because it has to hit an HTTP server and download the images, then that's an infrastructure problem, not a caching problem. So if your caching is disabled, your app should still work. Caching is everywhere. Could be caching an HTTP request, could be caching a slow database call, could be caching an image generation like a zip file or JPG, JPEG to PNG conversion, whatever. Everything can be cached. If it's a slow-running process, you can cache it. I'm going to repeat this one. Every 1 and 2 slides, it's your app should not fail when your cache is failing. So by the end of the presentation, you will know this. So rule number 1, when your caching is disabled, your app should still work. A simple example, geocoding an IP address. If you want to know where someone is from, their IP address is their computer host or computer address. If you want to know where they are, you have to geocode it. There's services for that. Google can do it. There's free GeoIP. There's all kinds of services where you can, web services, where you can do a call, give it an IP address, and it will give you the country and the location and stuff. But that's sometimes a slow process. And if the same user with the same IP address hits your server over and over again, you don't want to do the geocoding over and over again, because the same IP address results in the same geolocation every single time. So you can cache that. Same input, same output. First, you check the cache. If it's not there, you hit the server, the web service. You ask what the location is of the IP address, and you store it. And next time around, when the user comes in with the same IP address, you can just get that from cache. It's locally, it's fast, it should be fast. And you don't have to do the slow call to the external service. That's one of the benefits. If this external service goes down, your app is still working. That's one of the benefits. But rule number 1, your app should not fail. I was not lying. This is actually 1 and 2 slides is this slide. When your caching is disabled, your app should still work. By the end of this talk, you will know this by heart. You can actually cache on different layers. You can cache on the front-end side, your user agent, Chrome, Opera, curl, whatever. Everything can be cached on the front-end side. You can cache things on the web server side with Varnish or Nginx. That can cache some static files like CSS files or JavaScript files or images even. You can also cache on the application layer. The application layer is what we build, PHP developers. This is still a PHP conference, right? So on the application layer, we can cache some stuff, like the slow database calls. And then there's also op caching. If you don't know the specifics of PHP, PHP has 2 iterations over your code to convert it to machine code. The first one is changing the syntax to opcodes, and then from opcodes it goes to machine code, the thing that actually runs on your CPU, your processor. So it's in 2 steps, but if the source code doesn't change, the opcodes won't change, at least as far as my knowledge. It doesn't change. Even if it changes, it should still have the same functional effect. So you can also enable op caching. But rule number 1, if caching is disabled, your app should still work. This is why on your local computer, if your op cache is not enabled, which is on most development machines, which is disabled on most development machines, if your op cache is disabled, your caching is disabled, your app should still work. On your production server, you will speed this up by adding op cache. Rule number 1, your app should not fail when your caching is disabled. All right, let's move on to the next chapter. Caching in 2015. This was before there were any standards. Everyone was doing their own thing. Libraries were caching. There's geocoding libraries, packages on packages.org that do their own caching. There's frameworks that do caching, Symfony, Laravel, Zend, Cake, whatever. They all have caching. And then there's specific packages that do caching specifically. So everyone was basically doing their own thing. But a lot of people need caching, so there's a lot of opportunities to do caching. The problem is, you have your application with your framework, you set up caching, and then you import another package. And the framework has a couple of backends, storage backends for the cache. You may have set up Redis, and then you may have required another package with some more caching backends. But Redis might not be one of them. So you might need to write adapters or some kind of stuff to make it work. Because otherwise you will end up with a Redis store and a Memcache store. And your infrastructure people will hate you for that. So there's adapters everywhere. Adapters between frameworks and libraries, adapters between frameworks and caching packages, all kinds of stuff. And if there's no caching or no adapter available, you will still have to write it yourself or deal with 2 different backend stores, caching stores. That's not so optimum. So in December 2015, some people who did a lot of caching in their popular packages and frameworks like Zend and Doctrine, they decided on a standard recommendation, which is called PSR-6, PHP Standard Recommendation 6. It's a recommendation, not a standard. So if you all just agree on the recommendation, it's not a standard. You don't have to implement it. You don't have to do it, but there's a recommendation to use it. So it's finalized and accepted in December 2015. That's why I speak about caching in 2016. And the basic gist is there's 2 interfaces, one for a cache repository and one for a cache item or an entity. So repository entity pattern. And it goes like this. There's a cache item pool and cache item. The cache item pool is a repository. You always use the repository to query some items, 1 or more items. You get an item, you can get the key and get the value. You can also do isHit to see if it's available in the cache store or not. So the item is the entity, and it's not immutable, but the key is immutable. So if you have one item, it will always refer to the same item in the store because it will always have the same key. The key never changes. That's immutable. But the value can change. So you can set the value, you can set the expiration date or expiration time. Expires after or expires at, whatever you want to use. But what you should remember is that you never have to create your own item object. You always query the pool for an item. It will give you the item with the key and the value and the isHit all stored in the item object. You can then change that and save it back into the store. Is that clear? Never make your own items. You can also do multiple things at the same time, like getting multiple items. And you can also store multiple items. This is on a deferred basis, so you can add more items, and then at some point your item pool can decide, oh, well, I have 100 items, I can batch store that. Or you can say commit, and that will store whatever is currently deferred. If you have 50 items, but the cache item pool has not yet stored it to the backend, you can call the commit function, and then it will store those 50 items. So that's how it works with multi-actions. So you may ask yourself, what's wrong with get and set? Very simple. Well, this allows for extensions. So this implementation allows for an extended version of the repository and the item, so you can add more features, like cache stampede protection. I'm going to quickly explain what stampede protection is. It's basically a lot of people coming into your site and your server crashing because of a lot of requests doing the same cache item value calculation. So if a lot of people come in at the same time to your server and the cache item is expired, you have to recalculate the value. But if all of the incoming requests, some people have 50,000 requests in 1 second or in 1 minute, there's going to be a lot of incoming requests that are doing the slow database call, for example, or the slow image calculation. So we can solve that by, this is a timeline, by the way, it might not that clear. So there's a lighter version on the left, and that means the time is progressing. There's one incoming request, and the incoming request is before the load hits you, right? And that's going to execute a slow running task. That's the orange bit here. And when it's done, it's going to be stored in the cache item pool. Now, when time goes on, the load is increasing, a lot of requests are coming in, and they're all hitting the cache store. The cache store always returns the same value. And the expiration time is here, but this piece is darker because it means the expiration date is nearing. It's almost at its expiration date. And when one request comes in, just one request, right after this timestamp, it's going to say, okay, I am going to recalculate it. I'm also going to say that I am already calculating it, so no one else will start recalculating it. And then all the other requests coming in at the same time, they will say, oh, someone's already recalculating it, and the expiration date is here, so the expiration date is here, so I don't have to recalculate it. It's still fine, the value as is. I can still use it. When the one single request that is doing the calculation has finished, he or she is going to store it, and it's going to be unexpired or valid for a much longer period again. So you can set this timestamp to a very long date, and then just have half of that, and then start recalculating it. When the load is decreasing again, you will see that at some point in time, it's going to be expired. But that's okay. Load is low, and the first you're never going to get hit by 50,000 requests at the same time. Load is always picking up slowly and going down again. So there's always one request that's going to recalculate it. Unless this calculation takes 15 minutes, then load has 15 minutes time to pick up, but probably not. So this is stampede protection, right? Another feature you can add to the repository entity pattern is tagging. Anyone knows what cache tagging is? Not a lot of people, that's why you're here, that's good. It basically, you add some tags to items, and then you can ask the repository, delete all the items or drop all the items with this and this and this tag. So you can add tags to individual items, like add category 1 to this item, and then ask the pool to clear some items with these tags, right? Another feature is hierarchical caching. That's a hard thing to pronounce. I practiced for that. You can have keys with sharding, like you can have some slashes or whatever, or dashes to separate different layers in your keys. So you can actually do tree/star or users/star, and then delete all items that have a key that starts with tree/ or users/. You can delete not all of your cache store, but a partition, so that the recalculation doesn't have a big impact on your server or servers. Right. So that was all theoretical and what PSR-6 is about and how it works. But how do we actually start using it? Are there packages for it? Does my framework, can my framework handle it? So if we go to packages.org, we type in PSR/cache-implementation, we will see that there's a package for it with 0 downloads and 0 stars. And it also says virtual package. That's kind of weird, no? It basically means you cannot install this package, but you can install one of the packages that provides this implementation. So some packages, like Symfony/cache, they provide the implementation for PSR/cache. So if you click on either one of these, you will see that there's a little block in the bottom here that says provide. It has a requires block, requires dev, suggests, etc. But there's also a requires block. People from Composer added that, so you can have virtual packages. And this basically provides implementations to the interfaces that are defined in PSR/cache. The scheme is quite obvious. It says PSR/cache. That's still a valid package you can install. It says here as well. It requires these interfaces because otherwise PHP cannot implement interfaces that are not defined in a namespace and stuff. So you can install this package, install an implementation by installing this package because it provides the actual implementations to the interfaces. If you want to build your own package that provides those implementations, you can use a package called cache/integration tests, and it's this package. And this package basically provides integration tests for PSR-6. That's super easy. You don't have to write your own unit tests or integration tests. Just extend this one, extend this PHP unit test case, and it will have all the tests, something methods that will prove that your package is a valid implementation. Super useful. If you look on packages for implementations, you will see that there's a cache/vendor name, and they have all kinds of packages. There's an extension for tagging. There's an extension for hierarchical caching. There's namespace caching. There's also an array adapter, so it's in memory. There's also a void adapter. The void adapter is quite cool because remember rule number 1, if your caching fails, your app should still work. So if you just put in the void adapter, you will say store this, and next time you ask the same value, and it will say, I don't know, I didn't remember that. That's the void adapter. So it will just drop everything you tell it to remember. That's one way to validate if your app still works if your caching fails. Then there's also chain adapter, which allows you to store to multiple backends. So how do we start using that? There's all these kinds of packages, but does my framework use it or not? Can the packages that I use deal with this PSR-6 implementation? For libraries, it's basically they have their own caching adapters and stuff, so they will have breaking changes before they properly adopt PSR-6, but that's okay. Just leave it to the next major version. Whenever you're going to do some refactoring, just make a breaking change, add PSR-6 as well, and then you're finished. You can also have adapters, by the way. For frameworks, it's kind of the same. You can use some adapters. You can wait for the next major version. There's an adapter for Symfony, or it's not really an adapter. They just adopted it. Symfony/cache, since Symfony 3.1 or 3.0, they have proper PSR-6 implementations. There's also a Laravel bridge, which I made, sorry. This is an old screenshot, but there's 22,000 installs. To be fair, there's also cache/Illuminate adapter, but they only have 5 installs, so we win. Adoption. Who started using it? So there's some framework adapters, but which libraries actually use it? If you go to packages.org/packages/cache-implementation/dependencies, you can see which packages actually depend on implementations of caching to work. You can see that there's only 9 after 18 months. So adoption rate is pretty slow, I would say. But you can still use it in your frameworks by using adapters and stuff. But some people decided that the repository entity pattern was causing the slow adoption rate, so they said, I want a simpler version. Enter PSR-16, which is named PSR/simple cache. Instead of cache, simple cache. It was finalized and accepted in December 2016, 12 months after the first version, or PSR-6, and it's one simple interface. PSR/simple cache or /simple cache /cache interface. Super simple. Simple. Okay. One of the differences is if you get a value, it just returns the value or null when it's not set. But sometimes you need to store null as well if something is null, you know. So it's kind of hard to see whether the value is null or it's a cache miss, which people call it in cache terms. So you don't really know if it's cache miss or not. One way to solve this is to store a value object. Just store an empty value object that says the value was null. That's easier. It also supports multiple actions, batching, basically. So you can get multiple items at the same time, or you can store multiple items, or delete multiple items at the same time. So that's the difference between PSR-6 and 16. It's simpler, one interface. It doesn't know whether the value is null or it's a cache miss. And it also doesn't have deferring. So it has it has batching, but individual cache item pools don't have the knowledge to say, well, my best batch size is 50 or 100. It just has save multiple. Save these now. Don't wait till I have 100 or the optimum batch size. So deferring is not in this interface, but that's okay. It's simple cache. It's supposed to be simple. There's also, it still has these unallowed characters in keys. You can set a value with a key, a value, and an expiration date, but you can't use these characters, so they allow for future extensions. So again, practical. Who uses it, and how can I start using it? If you go to the same page again, we click on the virtual package, we can see that there's couple of implementations out there. There's a couple of packages that provide implementations for those simple cache interfaces. You can see, for example, a Doctrine adapter simple cache also adopts it. So a simple cache has PSR-6 and 16 implementations inside the same package. There's also the one on the bottom. It's pretty convenient. It's cache/simple cache bridge. So this basically bridges between PSR-6 and 16. So if let's say it was 2016 and you said, I'm going to adopt PSR-6 because it's awesome, because it's a recommendation. Sorry, it's not a standard, it's a recommendation. I'm going to adopt it. And then in December 2016, they said, well, here's a new version. Here's simple cache. It's simpler. And you want to use that as well because you're always living on the edge. Then you can already start using it by using this simple cache bridge. Again, there's integration tests conveniently in the same folder. So they updated this description, which now says provides integration tests for PSR-6 and 16. So you can, of course, you need to update a little bit, but that's okay. So upgrade path. How do we start using it? It's basically the same as PSR-6. Libraries, next version, or use adapters. Use adapters to PSR-6 and then wrap it with another adapter to PSR-16 if you actually want that. How is the adoption? A big null. There's no or zero. I checked this today. There's 0 people depending on this. So kind of sad, but okay, you can use adapters in your framework, in your application to use it. Oh, we have a lot of time for questions. Okay, let's do a quick recap. First, I talked about what is caching, why should we use it to speed up our app. What was rule number 1? Yeah, I hear some mumbling. When your caching is disabled, your app should still work. That was before 2015. Before 2015, we would all do caching, and we would all have our own interfaces and use adapters between frameworks, libraries, caching libraries, stuff like that. That's why they started with PSR-6, which is a repository entity pattern, which allows for extension to tagging, to use tagging and provide stampede protection and use hierarchical keys and stuff. There's all kinds of adapters. We can start using it today by using adapters. We can just bind all those to the IOC container and have our packages auto-resolve it, no problem. But some people decided that PSR-6 was too complicated and they just wanted the get and a set method, and also multiple could be simpler if you just drop the multiple. So there's room for a PSR-626. So yeah, PSR-16 has adapters too. You can adapt between 6 and 16 if you want to. Thank you.